Okay, so I'm live today and I'm going to continue episode 5 of 52 Weeks of AWS. And I'm going to talk about the Cloud Practitioner certification, a few more sections of it. And it looks like we're the penultimate version of the Cloud Practitioner material. There'll be one more week after this, and then I'll get through it. And then we'll just pick up another topic, maybe the Solutions Architect material. But I wanted to start off with, before I get into the Cloud Practitioner material, talk a little bit about some of the stuff I've been doing with C# in AWS. And what I will do is share my screen real quick and just get right into it. So let's go ahead and do that. And I will talk a little bit about some of the cool stuff that you can do when you're using the Visual Studio 2022 interface. So here's an example of some code that I'm using to interact with AWS. And I think what I'll do is first walk you through it, and then I'll show you how to install it and get it set up, and then I'll run it. So first up here, I have some imports. I'm using system.threading tasks. So this allows me in C# to do true parallel tasks, unlike languages like Python that have a global interpreter lock that stop you from true parallelization. C# does not have that problem. And in fact, they have really the ability to scale parallel tasks, in fact, and use all the cores on your machine. So that is very nice. The other thing is we have the ability to use Amazon S3 here. And this is through a var S3 client instance that I make. And if I hover over here, this is one of the nice things about Visual Studio, is that it gives you this great documentation about what it is. And this one in particular shows us this is a S3 client. And then if we go into here, I put a display prompt here. And then the next thing that I do is I use an await. And what's nice about await is it allows me to do full async calls. And in particular, I'm going to list all of the buckets in a completely async way. So I'm going to go in and get a bunch of data from AWS, essentially all the buckets I have, and then I'm going to count it. And why can I do that? Well, I can say list response, and the list response, which is a local variable here. What's nice about it is it comes with the ability to do buckets and count. And so I can go through here and just say, hey, give me a count of what's on the bucket. And then I loop through. And so I say, basically for every response inside of the buckets that come back from the API call, go ahead and write out the bucket name. And then this is the magic here. The static async method allows me to do the async call. So pretty neat little trick that you can do with the async to make things very performant. Now, how would you go through and build this out yourself? So what I'll do is first, let me just run it so you can see the output of this command. And you can see here, like really, really fast. You know, if I go through and I run it again, you can see here, just cranks through all the data and just lists out the buckets, right? Very, very simply. And then at the top of it, notice it has the count here, which again is really nice. And that is one of the things that I think people should at least be aware of, is that the performance you get from C# plus AWS is very impressive. Now, how would you build this out from scratch and get all this running? Well, you need to have Visual Studio, but also I'm going to go through here and close the solution and just show you a little bit of how to set it up from the beginning. So the first thing you would do is that you would say, I want to create a new project. And we would select, in this case, a project for creating a command line application that runs on .NET Core, on Windows, Linux, and Mac. So I'm going to go ahead and select that. And then we can just call this. In fact, I'll just put this somewhere because I'm going to throw it away. Just put it like, console app throwaway, so I know to get rid of it. And when I go ahead and I do next, it's going to ask me what framework, and I'm going to say I want to target the .NET 6, which is the latest framework for .NET. Let's go ahead and do that. And then now I've got a hello world. I can just go ahead and run this. Now, how would I get all of the magic AWS tools available to me? Well, the way you would do that is that you would go over to Tools and you select something called NuGet Package Manager. And when we go to NuGet Package Manager, you would go to Manage NuGet Packages for Solutions. We go through here, and then I can get access to tons of different things. Like, for example, a very common one people like to use is is actually ReSharper, right? So you can see ReSharper is a tool that does, code formatting and, syntax highlighting, all kinds of like refactoring for me. This would be an example of how you could install it. In this case, though, I want to do AWS SDK for S3. And if you go through here, you notice that here it is. I have access to it. And if I want to go ahead and select that into the project, notice that it's not installed. I just scroll down here and I click install. And that's it. It's trivial to install it. And now if I scroll back up here, you can see it's installed in the package. So very, very easy to build out. And then you just do what I did before, right? Is you do the imports for the AWS, S3 SDK and then do whatever it is you want to do with it. So just again, I'll give you updates on the stuff as I'm writing this book on C# for AWS. And this is one of the things I was working on today. And you can actually get access to this code if you go to GitHub. I have this available in .NET AWS instead of chapter 1 here. You can see that I've got this code. So if you want to take a look, again, GitHub NoahGIF .NET AWS in chapter 1 chapter, you can see I've got a full example project that you can just clone and play around with. Okay, so that's the update for this week with the AWS and C# book. Now I'm going to move on to Cloud Practitioner certification, and in particular, what I will do is talk through this material on networking and content delivery. I think today we'll be able to get through 3 sections. So I'm going to get through networking, content delivery, which is section 1 for today. Then I'm going to go to compute, and I'm going to go to storage. So actually some really meaty topics that we'll cover. So first up here, we're going to go through these topics like Amazon VPC, security, Route 53, and let's go right into it. So the first thing to be aware of is a computer network is a couple of client machines that are, or more that are connected together, and these allow you to share resources. And this can be, a logical, configuration or whatever it is you want to do. And in particular, this has things like a route that will have the traffic. And each client machine and network has a unique IP address with it. And so you may see this sometimes, 192.0.2.0. What that is it's actually a binary format. And each IP address is represented by 8 bits in octal format. So that means each of the 4 numbers can be anything from 0 to 255. And the combined total of the 4 numbers for an IP address is 32 bits in binary format. So just a little bit of trivia there. And a 32-bit IP address is called IPv4. And so you'll hear this a lot, like, IPv4, IPv6. The reason for this is that the IPv6 can accommodate a lot more devices. And so we're running out of room for IPv4. And so it's composed of 8 groups of 4 letters and numbers, and they're separated by colons. And so this means that the 8 groups can be anything from 0 to FFF. And the combined total of the 8 groups from an IPv6 address is 128 bits in binary format. So a common way to describe networks is a classless internet domain routing, or CIDR. And this is an expression where you've got an IP address, which is the first address, a slash character, and then finally you have a number that allows you to figure out the bits of the routing prefix. And so these bits are not always fixed to change. For example, in this one, the CIDR is 192.0.20/24. And the last 24 here tells you are 24 bits that must be fixed, and the last 8 bits are flexible. And so the 4th decimal digit is allowed to change from 0 to 255. So there's a little bit of trivia here with these CIDR routing. And so the open internet Open Systems Interconnection, or OSI model, is a conceptual model. You'll hear this quite a bit in like networking exams, and this explains how data travels over a network. And so layer 7 would be means an application can access a computer network, and this would be things like HTTP or HTTPS, FTP, DHCP, or LDAP. And then there's a presentation layer, which is number 6, or layer 6, and this ensures that the application can read data encryption. So this would be ASCII, would be the protocol. Session 5, or session is the Layer 5 enables orderly exchange of data, and this would be NetBIOS or RPC. Transport would be 4. That would be a protocol for host-to-host communication. So TCP and UDP. So this is a lower level of communication. And then you have layer 3, which would be routing and packing, forwarding, so routers. So this would be IP-based in the model. And then you've got data link, which is 2. That would be transfer data in the same LAN, so hubs and switches, or MAC would be the protocol. And then you've got physical. So this is transmission and reception of raw bit streams over a physical medium. So signals like 1 and 0. So, this is an important thing to be aware of, is like, where are you on this OSI model? Like, what layer are you working at? Okay, let's talk about VPCs here. And so a lot of the concepts of a network apply to cloud-based networks, but there's a little bit of difference. So to start with, a VPC allows you to provision a logical, isolated section of the cloud where you can launch resources in a virtual network that you define. So it's really, you're designing a system from scratch. Because it's virtual, you can give it control over anything you want. And you can have IP addresses, subnets, route tables, network gateways. So you have complete control to create a virtual world. So I know a lot of people talking about things like the metaverse and all this stuff. Well, this is the same concept as whatever you can imagine you can do inside of this virtual networking. And this enables you to use multiple layers of security all at once. And so VPCs and subnets, VPCs are logically isolated from other VPCs. They're dedicated to your AWS account, and they belong to a single AWS region. You can span multiple AZs or availability zones. And so you can see here, this is a diagram where inside of your region here, you could have multiple availability zones, and the VPC would basically span across those. And a subnet is a range of IP addresses that divide a VPC, and they belong to a single AZ. And they're classified as either public or private subnets. IP addressing enables resources in your VPC to communicate with each other. And so when you create a VPC, you assign an IPv4 CIDR block or private IP addresses. And so you can't change address after you create the VPC. The largest IPv4 CIDR block address is 16. The smallest is /28. And IPv6 is also supported, but with a different block size limit. And CIDR blocks of subnets cannot overlap. And a reserved IP address is pretty interesting, because a VPC with an IPv4 CIDR block of 10.0.0.16 has a total of 65,536 total IP addresses. The VPC has 4 equal-sized subnets, and so there's only 251 IP addresses are available for each subnet. And you can see here that typically when you're creating basically these reserved IP addresses, this is kind of similar if you're setting up something at home, that 10.0.0 would be the network address, 10.0.0.1 would be internal communications, 10.0.0.2 would be DNS, 10.0.0.3 is future use, and 10.0.0.255 is network broadcast address. Now the public IP addresses, these are manually assigned for an elastic IP address, and they can be assigned through auto-assign public IP address settings at the subnet level. And elastic IP addresses, they're associated with an AWS account, and they can be allocated and remapped anytime, but they do require a cost. And so elastic IP are pretty cool, because you can actually have a service that underneath the hood, the machines are changing, but the IP address stays the same. And the reason for this would be, especially in the case of DNS hosting, you don't want to be swapping up constantly and changing the underlying IP address, because you want the host name to map to a static IP address. So Elastic Network Interface is a virtual network interface that you can attach to an instance and detach from an instance and attach to another instance to redirect. And it does the attributes basically follow it when it's reattached to a new instance. And so again, the primary use case for this would be, let's say, a load balancer that's got some instances associated with it. You would have a static IP address potentially that could correspond to either a physical machine or to maybe a load balancer. And the idea here would be that when you swap the things out underneath, that it doesn't care what's happening in terms of the machines, that the host name is always corresponding with the same IP address. And so this would have zero downtime if you swapped out the underlying components. Route tables contain a set of rules that you can configure to direct network traffic from your subnet, and each route specifies a destination and target, and by default, every route table contains a local route for communication within the VPC, and each subnet must be associated with a route table. And another thing to be aware of here is that a VPC is subdivided into multiple subnets, and route tables control the traffic for a subnet, and a local route can't be deleted. So these are good things to follow up on that really could trip you up in an exam. Let's talk a little bit more about the VPC networking. And so an internet gateway is something that is a scalable, redundant, and highly available VPC component that allows the communication between an instance in your VPC and the actual internet. An internet gateway serves two purposes. The main reason is to provide a target in your VPC route traffic table for internet routable traffic, and to perform network address translation, or NAT translation, for instances that were assigned public IPv4 addresses. And to make a subnet public, you would attach an internet gateway to your VPC and add a route to the route table to send non-local traffic through the internet gateway to the internet. And you can see a diagram of this. So what is NAT, or network address translation? It enables instances in a private subnet to connect to the internet, but prevents the internet from initiating a connection with those instances. So really it's a one-way pathway. So in the case of NAT, you essentially are able to provide access outside, but they can't get to those instances inside. And so this is a great secure way to build out a service. And in the case of VPC sharing, this enables customers to share subnets with other AWS accounts in the same organization in AWS organizations. And this sharing enables AWS accounts to create application resources such as EC2 or Lambda or whatever. So you can see here that this particular region has private subnets, public subnets, and inside there's a VPC that maps it all together. Now, VPC peering is something that's pretty interesting. You'll see this a lot with SaaS services like Databricks or Snowflake or these kind of services where you actually have a peering system set up that enables you to route traffic between them privately, and these instances can communicate with each other. And so when you set up a peering connection, you have rules in your route table to allow the VPCs to communicate with each other. And so this, again, is something to be aware of that you'll especially see with SaaS-based services, especially services in the data space. And there's also AWS site-to-site VPN. And this is something where by default you launch instances into a VPC and they can't communicate with a remote network. And so instead you need to create some kind of a virtual gateway device, a VPN, and attach it to the VPC. And then you define the configuration of the VPN or customer gateway, and you create a custom route table. So I've done this quite a bit when I'm using a VPC, is that if I want to access, for example, S3 and have S3 inside the VPC where no one else can get access to it but people that are on the VPN, you just attach the VPN into your private VPC and then you get access to it in a secure way. So this is a very great method to build out like development environments, for example. And then there's AWS Direct Connect. And this solves one of the challenges of network communication, which is network performance, and it can be negatively affected if your data center is far away. And so in those situations, the Direct Connect enables you to establish a dedicated private network connection between your network and one of the DX locations. And so you can read up a little bit more about this as well, but basically this is a custom setup that allows you to have very good performance with your data center and AWS. Now, in terms of VPC endpoints, it's a virtual device that enables you to privately connect to your VPC and the VPC endpoint. And so these services don't require an internet gateway. And you can see here from this particular endpoint, for example, that you're able to get access to Amazon S3 service. And so again, I've mentioned in the past that I've used these kind of configurations to do development where I want everything privately located inside of a VPC, but I want to use it in my particular private development environments, and I don't have to worry about exposing it to the outside world, so people see my local development environment in progress. Now, there's also AWS Transit Gateway, and you can configure your VPC in several ways and take advantage of numerous connectivity options and gateways. And in particular, this is one of the ways that you could actually configure this, and you could actually have Transit Gateway in the middle here, and it would be using things like VPN connection and all this to tie it all together. Okay, here's a good example of a diagram, and in general, I'll just say it's a good idea to get used to building out your own network diagrams. It's a great way to learn. Okay, so let's get into VPC security a little bit. A security group is a virtual firewall for your instances, and you'll see this come up all the time when you're launching instances. And so the security groups act at instance level, though not the subnet level. So each instance in a subnet can be assigned to different sets of security groups. So the most basic way to describe a security group is it's a way to filter traffic to your instances. So think of it as a firewall. So security groups have rules that control both inbound and outbound traffic. Most of the time, people care about the inbound traffic, but you can basically deny outbound traffic as well. And so when you create a custom security group, and this would be if you wanted to set up, let's say, web development with port 8080 or SSH into a machine or whatever it is you want to do, you would have to go and create a custom security group. And then I think it's a very good idea as well to describe a name for that security group so you know what it is and you can use it in the future. A network access control layer, or ACL, is an optional layer of security for your VPC, and it acts as a firewall for controlling traffic in and out of the subnets. And so you can use this as well to control the security of your system. And network ACL has separate inbound and outbound rules, and each rule can allow or deny traffic. And so they're stateless, which means there's no information about the request is maintained after the request is processed. You can also create custom network ACLs as well that do things like deny all inbound or outbound. And so these are also very powerful tools that you can use to secure your network. And so basically, there's security groups versus network ACLs. And so security groups are instance level, network ACLs are subnet level, so they're obviously more powerful. They can apply to a whole group of machines in a subnet. And supported rules, they allow rules only with security groups, but you can do allow and deny rules with network ACLs. And they're both stateless, and in terms of rules order, you can read up more about that in the official documentation. So let's talk a little bit about some of the final things here. There's Route 53. So Route 53 is a DNS service, domain name system, web service, and it's pretty amazing because of the deep integration with the Amazon platform. I use it myself. It's used to route users to internet applications by translating names into IP addresses, and it's compatible with IPv4 and IPv6, and it's used to check the health of your resources, feature traffic flow, and enables you to register domain names. And so in terms of Route 53 DNS resolution, you can see that it returns an IP address, and basically that's what a DNS resolver does. And you ask for a name that returns back an IP address. So there's a few different routing methods to be aware of, and these are things that are actually really powerful to know about in terms of building sophisticated architectures. There's the simple routing, which is round robin. And so this is for a single resource that provides a function for your domain, like a web server. There's weighted round robin, which uses to route your traffic to multiple resources in the proportions you specify. And so you could do like A/B testing for this, for example, where 75% of the traffic goes to one set of machines and 25% goes to another, if you're, again, testing out some kind of a feature. There's also latency-based routing, which is pretty nice because you could use this to detect whether, if you had, let's say, instances all over the world, you could actually do some kind of a LBR where it says, oh, hey, things are very latent, And so let's try another instance, and let's bring it to this other set of machines, and then this will actually improve the performance. There's also something kind of related, which is the geolocation routing, which is you can specifically route users to a particular geolocation. And this might be something that you would use in the case of the European Union, where they have different data protection laws. And so by law, you may not even be able to use things like geolocation routing, because you're required to keep, let's say, the European data in the European location. There's also failover routing. So this is when you want to configure an active passive failover. And so Route 53 can help detect outages of your website and then redirect your users to alternate locations. And then there's multi-value answer routing. So this is when you want to use Route 53 to respond to DNS queries with up to 8 healthy records that are selected at random. So that's kind of a cool ability as well. And this particular could be used for multiple kinds of things. Basically, it's a way to use DNS to improve availability and load balancing. So a lot of things you can do with Route 53. So one use case would be multi-region deployment, where you would have latency-based routing and load balance routing to availability zones. Again, you want to check out where a user is coming from and then give them the right resource. There's also, with Route 53 DNS failover, you can improve the availability of your application by configuring backup and failure scenarios, and also enable things like multi-region architectures and create health checks. The DNS failover for a multi-tiered application, really in a nutshell, it would be you would create a couple different DNS records for the CNAME www with a routing policy of failover routing. And the first record is a primary route, and the second record is the secondary route policy, which points to, let's say, static S3. And then you'd use Route 53 health checks to make sure the primary is running. If it is, then it defaults to the web app stack, but it could fail over to the static site, right? So you have this like rich, real site that's serving out traffic to a database. But then if you have a problem, it could go to a static version of your site. So it's, I think, a pretty cool setup there for many organizations. And then we have CloudFront, again, another service I use. And what's nice about it is that it allows you to really improve the latency of media requests. And so it's a globally distributed system of caching servers. It caches copies of all kinds of content like HTML, style sheets, JavaScript, media files. And so what's nice about it is that it establishes and maintains a secure connection that's closer to the requester. And so that's really the main idea with a CDN, is that you're actually putting the data all over the world, and whoever is closest to it in terms of where the host is, it'll give it to the user. And so with CloudFront, it has a pay-as-you-go pricing, and especially for static hosted websites that are on S3, you can actually tell S3 to put the data into CloudFront, which is what I do for my websites, and then they serve it out from a fast, global, and secure CDN service. And it's actually very straightforward to set up and cost-effective. Now, the infrastructure for CloudFront is that they have edge locations. These are network data centers that they use to serve popular content. And they also have regional edge caches. And these are where the cached content is not popular enough to stay at an edge location. Basically it will decide for you where to put those. So really, what are the benefits of CloudFront? Fast, global, security at the edge, highly programmable, deep integration with AWS, and cost-effective, and in my opinion, ideal for static websites. So how does it work? You get data transfer out. You're charged for the volume of data transferred out from CloudFront Edge, HTTP requests, so basically how many times people are requesting it, and then invalidation as well. So as long as you're not charged for the first 1,000 paths that are requested for invalidation, afterward it's 0.005 per path that's requested for invalidation. So the idea here is that, let's say you publish a new blog post, I don't know, once a week or something, like you're not going to get these charges because you're invalidating the cache on an infrequent basis. But if you're invalidating tons and tons of paths per month, you might start to get some charges for the invalidation. All right, so that's really it in terms of networking. I'm going to move on now to the next section I want to cover today, which is compute. So let's go ahead and dive right in. Now, in terms of compute, what's kind of cool about compute here is that there's a lot of stuff on AWS in terms of compute. And here's a good example of the services. We've got EC2, Beanstalk, Lambda, Fargate, container registry, Kubernetes service, ECS, right? These are all tons and tons of services. And we're going to talk about basically the service I just mentioned, but there's other services as well, like Outpost, serverless application repositories, batch. All right, so let's dive in here. Let's go into the categories, and in particular, the categories here to talk about are going to be these compute services. So I'm going to go ahead and by the way, just share this particular screen here to make sure that we've got this thing going. So basically, in terms of categorizing compute services, we have Amazon EC2. This would be infrastructure as a service, so lower level. This would be instance-based virtual machines. We also have the ability to provision virtual machines that you can manage as you choose. And it's a familiar concept to many IT professionals. So EC2 is really like maybe the first thing you'd reach for in terms of compute. Lambda is serverless, and so it's function-based. So you can just have an input, have an output, build it out. And it's low cost. You can write and deploy code that's triggered on an event. And also it's architecting for the cloud. And it's a relatively new concept for many IT staff members, but it's easy to use after you learn how. And then there's container-based, which would be ECS, EKS, Fargate, ECR. You can spin up and run jobs much more quickly than virtual machines. So that's probably one of the bigger takeaways, is that the virtual machine technology is an older technology and much slower. And Fargate, for example, would reduce the administrative overhead, or things like, for example, the EKS service as well could potentially reduce the speed, reduce the spin-up time for machines. AWS Elastic Beanstalk is a platform as a service offering. This allows you to focus on a code, and you can do things like tie this into databases or domain name systems. So again, those are the general categories. And just a few things I'll point out here is there you've got infrastructure as a service, you've got serverless, and then you've got platform as a service. And things are a little bit squishy between those things, but infrastructure means you do more work, and platform as a service means you do less work. And I typically like to go for less work. So how do you pick the right thing to, you have to know about your application design patterns. That's one way to know about it. Usage patterns, configuration settings. Basically you want to make sure that you're selecting the right solution so you can be efficient. So let's get into EC2 first. Good use cases for EC2 would be, web servers, media servers, file servers. And in particular, these are virtual machines that are referred to as EC2 instances. You can run Windows, you can run Linux, and you also now can run OS X. And you can launch instances of any size. I mean, I was just playing around a little bit ago with machines that were 96 core machines that are available on AWS. And it's trivial, right, to just launch one of these big machines. You also can build out your own AMIs, or Amazon Machine Images, and actually pre-bake it so that it's got everything configured the way you want, and you can control traffic to and from these instances. Now, in terms of launching an Amazon EC2 instance, one of the things that you can do is launch it via the console. That's probably one of the easiest ways to do it. And there's essentially 9 decisions to make when you launch. And so the first thing is select the AMI. So I would recommend to start with use the Amazon Linux 2 AMI, but you can use things that have potentially pre-installed software inside of them. There's also things like Quick Start, My AMI's AWS Marketplace, so you can buy, for example, like a pre-configured instance. And there's community AMIs, like somebody configured, some kind of a web service or something like that, and you could configure it, or Jupyter Notebook or something. So when you create a new AMI, the main thing to be aware of is that these AMIs here, you do have to actually snapshot these things and make sure that you're able to create like a golden instance when you build it up and save it and then copy it. So in terms of instance type, The other thing to be aware of is that there are types that have more memory, more processing power, more disk storage, more networking performance. Every one of those things you have to configure. So a great example would be when I've done huge clusters of machines that I've spun up. One of the things that's not as obvious is that the bottleneck could actually be the network and not the CPU, because it's a virtual environment. If you don't have enough fast bandwidth and you're using, let's say, a network file system like EFS, that could then become your bottleneck is the network. And so you do have to be aware of all of these characteristics when you're choosing the instance type. In terms of network settings, again, those can really be a bottleneck. And so how does the instance type naming take place? So in the example of a T3 large, a T is family name, 3 is the generation number, and large is the size. So here's some good examples. General purpose could be A1, M4, M5, T2, T3. The use cases, they're just general purpose. They're broad. Compute optimized, they'll have the C inside of them. So C4, C5, they'll be high performance. Memory optimized would be R4, R5, X1, Z1. There could be things for, like, let's say a Redis cache, right? Like an in-memory database, or SQLite or something like that, or Postgres in-memory database. The accelerated computing could be F1, G3, G4, P2, P3. Typically, people use those for machine learning because of the GPUs. Then you got storage optimized, D2H1 or I3, things like a distributed file system, which again are making a big comeback. These would be a good use case for that. So in terms of instance types here, we got networking features. The network bandwidth varies by instance type, and you can actually check that out on your own. And in particular, to maximize network and bandwidth performance of your instance type, you probably want to launch them into a cluster placement group and enable enhanced networking. And enhanced networking is supported on most instance types. And so what does it do? It supports speeds of up to 100 gigabits per second. And in terms of the Intel 82599 virtual function interface, it supports network speeds up to 10 gigabits per second. So as I mentioned earlier, networking can really be one of the subtle things that you have to pay attention to. I personally would prefer to use the best networking that they give me. So in terms of network settings here, a thing to be aware of is the VPC and optionally the subnet that would be available to, and also the public IP address should it automatically be assigned to make it, let's say, internet accessible. You could also attach an IAM role. And this is very interesting. Like, I think that many people are confused about like IAM roles because they want to create, let's say, an API key and put it on the machine, which is a no-no. What you want to do instead is you want to create a role inside of AWS IAM and then give that particular instance access to that role. For example, I want you to read from S3 and use the principle of least privilege. Don't give it more privileges than it needs. So the other thing that I've used quite a bit, and I actually have some Python code where I call into this API via Boto3, is that you can send a request to an instance with user data, and you can basically tell it before it even launches, hey, install the software, mount this, elastic file system, whatever it is you want to do. You can even tell it to die after 30 minutes, which is one of the things I like to do, is you tell it to basically after 30 minutes, die, because I want to make sure I don't forget to throw the machine away. You can put all these kind of things inside of user data, and you can call it from Python, which is one of my favorite ways to launch machines. You can specify the storage. This is another one that's a little bit tricky when you're launching the machines, is that you don't necessarily want to give it more than you need, because that could actually give you a lot of costs associated with it, but you can configure very large machines. So what are the options? We have EBS, which is the block level storage, which means that you can assign, really robust disk I/O to a machine. And this could really be something to be aware of as well. It's easy to get performance problems if you don't have enough disk I/O in addition to networking. You also could get ephemeral, and this would be, basically you don't care, the data can be deleted. Another option that I personally really like quite a bit is that You can mount elastic file system, again, with things like user data, which I like because of the convenience of having the same data available as a mount point to the entire cluster. Storage examples here would be like Amazon EBS root volume, could be where the operating system is stored, and you would attach it, and then you'd have another storage volume, and then you could detach that storage volume, for example, and reattach it to another machine, or you could archive it. So that's probably a good way to configure your instance. Tags would be something where you could just assign it. Let's say you had the data science department and the development department. For example, every time they launch machines, you could tag them with the name of their department, and then you could do a cost analysis to make sure that people aren't going over their budget. Security group settings, we already talked about security groups, but basically it's a set of firewall rules that control the traffic to an instance, and they allow you to do things like, for example, SSH into machines. And so if you don't do this when you first launch the instance, you're never going to be able to log into it. And that's an easy way to burn a little bit of money as you go, oh, wait, what's happening is you forgot to attach a security group before you launch the machine. Now, identity or create the key pair, there's another one, like you must have a key pair associated with it. Again, you're not going to be able to get into the machine if you didn't have a key pair associated with it. Now, in terms of the EC2 console, it has a reasonably good way of looking at the running EC2 instances. I think I've mentioned this before. Visual Studio 2022 also has AWS Toolkit, where you can actually use it to look at the instances as well. But basically, console is a pretty good view of running instances. Another thing you can do is you can launch EC2 from the command line, or you can even launch it with Python. I have a bunch of Spot instance launch code in my GitHub. But yeah, command line is a great way to launch it. Now, the life cycle here is you have launch, it goes pending state, it's either running or it's stopped or rebooting. It can terminate, shut down, and basically you have this whole life cycle where you choose what do you want it to be: rebooting, running, stopping, shutting down, terminated. Now, with an elastic IP address, one of the things to be aware of is that you can associate it with the machine, and the IP address will still be around, but it won't be associated if the machine is stopped. When it's launched again, then it gets hooked back up. The metadata is the ability to talk to the local machine. So I've written code before that talk to the metadata of instances. What's nice about it is it can tell you a bunch of data about your machine, because you may not know everything that's happening unless you ask the machine itself to tell you what's happening. And so it's a great way to manage a cluster of machines. CloudWatch is a tool you would use for monitoring. So you can do things like look at everything in your cluster, look at the CPU usage, the memory usage, and then build out dashboards for those things. You can also enable more detailed monitoring, like, basically metric data delivered every 1 minute. Okay, so in a nutshell, there's a lot of powerful things you can do with EC2. And one of the best ways to do it is to just use it. Okay, so let's get into pricing models. So this is something that's an easy one to miss. Is there's on-demand instances, there's reserved instances, there's spot instances, there's dedicated instances, there's scheduled reserved instances, and there's dedicated instances. So in a nutshell, most people start off with on-demand, pay by the hour, no long-term contracts. The one that I would recommend immediately you probably start taking a look at is spot, because you can actually get a huge discount, let's say up to 80%. And a lot of times you just want to play around with instances. And then the next one, it would be things like reserved instances. So you can save a lot of money if you know what your capacity is going to be. You reserve these instances for 1 or 3 years. The pricing model, you've got on demand, which is low cost and flexibility. Spot would be, things like clusters, dynamic workload. Reserved would be predictability. You already know what you're going to spend. Dedicated host could save money on things like licensing cost. So spiky workloads would be on demand. Time insensitive workloads would be spot instances. So you have flexible start and stop times, or users have urgent compute needs for large amounts of additional capacity. Steady state workloads would be reserved instances, and then highly sensitive could potentially be dedicated. So it is important to know those differentiations between the pricing. There's 4 pillars of cost optimization: right size the increased elasticity, and the optimal pricing model, and also optimal storage choices. Now, pillar one, right size, that would mean the provision instance, it must match the needs. So CPU, memory, storage, network throughput. In terms of Amazon CloudWatch metrics, you want to look at things like, are the instances idle, or are they busy, and then pick the right size. For elasticity, that means that you have the ability to stop or hibernate instances and use automatic scaling, right? You don't want to be over provisioned and then have it very difficult to bring it back down, or vice versa. That's why the auto scaling elasticity is so critical to controlling costs. The optimal pricing model would mean you leverage the right price for your use case. So again, if you're not, if spot instances work for you and you're not using them, you're wasting a lot of money. Also optimize storage choices. So, resize volumes if you've allocated too much, because you are going to be charged for those extra gigabytes. And also potentially, if you're not using the disk IO, then go to a lower based disk IO, or delete the EBS snapshots. It's really easy to have all these extra snapshots and then you don't even need them and you're just spending too much money. So measure, monitor, improve. It's an ongoing process. So I think it's easy to think that you don't need to do this until you start spending too much money. Okay, container basics. They're a method of operating system virtualization. And so the benefits are they're repeatable, self-contained environments. They run the same in different environments, developer laptop, test, production, and they're way faster to launch or terminate than VMs. And so what's Docker? That's typically the place people are using. It's a software platform that enables you to build, test, and deploy. And so there's Docker Desktop, which is what most people are using on their desktop, but it also has Docker Hub. You can push container instances there, but it's really the format. It's the file format, a Docker file format that now modern container registries like ECR or Elastic Container Registry use. A container has everything, the entire runtime and the application inside of it. So container versus a VM. So basically, a VM includes, more of the operating system, and the container contains less. That's probably one of the best ways to think about it. And in terms of Elastic Container Service, or ECS, it is a highly scalable, fast container management service. It orchestrates the running of Docker containers, and it maintains and scales the fleet of nodes and removes a lot of the complexity from creating the infrastructure. And so it's integrated with other services like EOB, EC2 security groups, EBS volumes, and IAM roles. The orchestration service allows you to basically build this out in a way that scales. And some of the options are basically, do you want to manage the cluster? If so, then you can create an ECS cluster. If you don't, then you just use Fargate. So what's Kubernetes? Kubernetes is an open source software solution for container orchestration, and it also does the same thing as ECS. It complements Docker. It enables you to run multiple containers on a single host, and Kubernetes orchestrates multiple Docker hosts. And so it does things like automates container provisioning, networking, load balancing, and scaling. And so EKS is the managed service that allows you to run Kubernetes on AWS, supports Linux and Windows, and it's compatible with Kubernetes community tools. And so what would you do with EKS? You would manage clusters of EC2 instances and run those containers via an orchestration inside of EKS. So the ECR, which sounds like the other two, ECS and EKS, is the container registry itself. So it would be similar to, for example, Docker Hub, but it's a private hosted service inside of Amazon that has the ability to take charge of all the integration with Amazon. And so it has Docker support, team collaboration, access control. So if you're going to be deploying containers on the AWS platform, you must use Amazon ECR. Okay, so let's now talk about Lambda, my favorite service on AWS. Why do I like it so much? Because it's easy to use to build stuff. And so Lambda is a serverless compute service. It allows you to run code in response to events. And the code will only run when it's triggered, and you only pay for the compute time that you use. So what are some of the benefits of Lambda? It supports multiple languages like C# and Python and Ruby and et cetera, et cetera. It's completely automated. Also has built-in fault tolerance, and it supports the orchestration of multiple functions and pay-per-use pricing. So what are some of the event sources? It's things like S3, DynamoDB, SNS, SQS, API Gateway, Application Load Balancer. So really, if you like building solutions, Lambda is probably the quickest possible way, especially because of the fact that it's event-based. And how does it work? You got the code dependencies, which would be like the libraries and execution role. AWS Lambda function, for example, allows you to run your code only when it's triggered, and then do things like Amazon CloudWatch metrics. So schedule-based Lambda functions would be starting and stopping EC2 instances. So time-based CloudWatch event, Lambda function triggered, EC2 instances stopped. Time-based CloudWatch events, EC2 instances started, right? You can do all these really powerful things with Lambda by responding to events. And a great example of Lambda would be you put some images into an S3 bucket, it triggers a Lambda and converts them to a new file format, or does like labeling where it figures out what's inside of the image. Quotas are, with Lambda, you can do by normal, it's 1,000 concurrent executions. Function layer storage of 75 gigabytes. The function timeout would be a hard limit would be 15 minutes. And the deployment packet size hard limit would be 250 megabytes unzipped. And there's other limits as well. In a nutshell, there's a lot of stuff you can do with both Lambda and EC2, and also with containers. The final one we'll talk about here is EBS, which is Elastic Beanstalk. Definitely been around for a lot longer, but it is pretty cool because it manages a virtualized environment via a load balancer. It's a platform as a service deployment, so it's got things for Java, .NET, PHP, Node.js, Python, Ruby, Go, Docker. And so you just manage the code, it manages everything else, the OS, everything, and it deploys on servers like Apache, Nginx, Passenger, or IaaS. Why would you use Elastic Beanstalk? Well, it's fast, easy to use. Basically, platform as a service allows you to just write code, push a button, and deploy it. And in the cases of things like .NET, you can literally just right-click and deploys your application. So really, that's probably it in terms of compute here. Let's move on now to the last thing I'm going to talk about today, which is storage. A pretty big topic, but let's go ahead and take it. Here we go, presenter view. So in terms of storage, I think a few things to talk about here are these are core services. And really the big ones are Amazon S3 object storage, EBS block storage, EFS would be network managed file system, and then S3 Glacier backup system. So let's first get into EBS. The idea here with EBS versus object storage is you can change a small amount of data. Object, it's all or nothing. So if you had a terabyte file inside of S3, you would have to change the entire terabyte file. Block storage, you just change a little bit of it. EBS enables you to create individual storage volumes and attach them. And so what's nice about this is that you can go through and do a lot of things that you would typically do to a traditional file system, right? So you can do, snapshotting, and you can back them up to S3, and you can use them as a boot volume. You can host databases on them, all kinds of really powerful things with EBS. And so they have SSD drives or HDD drives. In terms of the solid state, those are definitely the ones that have really good performance. And they have general purpose IOPS could be all the way up to 16,000 IOPS, which is incredible. But you can even provision more IOPS and get to 64,000 IOPS. The HDDs, the IOPS are very bad. But they're not. If you don't care about IOPS, they're very cheap. So and traditionally it's maybe anywhere from 200 to 250 to 500 IOPS. So SSDs, why would you use it? Most of the time, you probably want to use SSDs. They're just very quick and powerful, and they give you burstable performance. The HDDs, why would you want to use it? Let's say you have a streaming workload and you don't really care about disk performance because it's in memory. You're using big data, or you're basically doing log processing. So with Amazon EBS features, one of the things it can do is snapshots, which is incredible, right? You can create snapshots and store them in S3. You can encrypt it, and you also have the ability to scale up in terms of disk I/O or size. The main things to be aware of are you have basically volumes, IOPS and pricing. Volumes, is that these volumes are independent from the instance. IAPS, you have the SSD, magnetic, and provision IAPS. Snapshots, these would be an added cost, right? Because you're storing those snapshots to S3, and that would be the gigabytes per month. Data transfer, inbound data is free, outbound does cost. Okay, let's talk about, essentially the next section here, S3. Basically, S3 is a managed storage solution that allows you to have extremely durable, durability. So basically 11 nines of durability. So 99.9999999 11 nines essentially of durability. So essentially your data is very difficult for it to get lost, but a single object would be limited to 5 terabytes, but the data is stored as objects in buckets. And so there's a lot of different tiers about Amazon S3. I think that's a big thing to take away. There's standard intelligent tiering, standard infrequent access, one zone infrequent access, Glacier, and Glacier Deep Archive. And this is probably one of the more confusing but also powerful things about S3 is that pick the right one for the right job at hand. And so the other thing to be aware of is Amazon S3 has two styles of buckets. One is the bucket path style. The other is the virtual hosted style. In general, it would be HTTPS S3 dot the region code, and then Amazon AWS.com, and then the bucket name. The bucket virtual hosted style would be HTTPS the bucket name dot S3 hyphen whatever the region code is, like AP Northwest Northeast 1, and then Amazon AWS. So the data is redundantly stored in a region. That's really important to know, and so you don't have to worry about it being lost. And it's also designed for seamless scaling, so it'll automatically scale according to the requests, and you don't need to worry about provisioning more storage, etc. You can access it from the console, the CLI, the SDK, and even things like the AWS Cloud 9 environment. I do that a lot. Is you can actually see it inside and just right-click on it and download it. A common use case would be application assets, static website hosting. I've mentioned this before. I have a ton of static websites that I deploy automatically to S3. I think it's incredible for that. You can use it for backup. You can also do big data. I've done a ton of big data stuff with S3 as well. So S3 common scenarios would be, again, backup, media hosting, software delivery. With pricing, you only pay for what you use. So it's gigabytes per month, transfer out to other regions, and things like put, copy, post, list, and get requests. So basically, HTTP methods are how you're charged, but you're not charged from transferring the data in. So how would you estimate the pricing? It would be like, first you have to pick the class of storage, right? Do you want to use infrequently access or standard storage? Also, how much are you going to store? How many requests are you going to make? And then data pricing, and you can do a calculation. But in general, S3 is very cost effective. Okay, so what about EFS? It's a managed network file system, and in fact, it works well for big data and for analytics, web serving, home directories, petabyte scale, low latency file systems, shared storage, elastic capacity. It supports NFS. So I've been using NFS for 30 years. And NFS is awesome because it allows you to mount the file system and basically it becomes a home directory where you can put your user data in and things like your bash RC file or potentially, share out maybe like a web service, and all the different machines all have access to the same data. So the architecture could be that you have multiple machines that mount a elastic file system mount point. I again like to put them into, let's say, spot instances, so that always my spot instances have access to a mount point through user data. Or you could bake it into the AMI as well. With Amazon EFS implementation, you basically just create the file system and they manage all of the scaling for you. You only need to know things like, security groups and the VPC subnet, things like that, and it'll do the rest for you. Okay, Glacier is the archiving system for Amazon, and it's extremely low cost. In the old days, they would have like tape backups. In this case, you would just use Glacier. And so in a nutshell, you're going to only be charged basically by retrieving the data. And that's what's kind of interesting about this, And so in terms of a standard retrieval, there's bulk retrieval, and there's expedited. Obviously, expedited will cost a lot more. So what are the use cases? Media asset archiving, healthcare information archiving, those kind of things, tape replacement. You can control it via web services, SDKs, lifecycle policies as well. So you can tell buckets to automatically archive things, which I think is a very good idea. If it's not automated, it's broken. And so the policies allow you to do things like once you put it into standard storage, maybe after 30 days, it moves into infrequently accessed. After 60 days, it moves to Glacier. And then maybe after a year, it gets deleted. And I think that style is a very good style to use S3 because, if it's not automated, it can be very easy to make huge mistakes. And I've made huge mistakes on S3 before. Comparisons, there's no limits of data volume with Glacier or S3. But in terms of item size, Glacier can take 40 terabyte maximum item size. It's also much lower cost, but you're charged by request and by gigabyte. And so in terms of encryption as well, it's used throughout Glacier, and you can also control things via IAM. And so, really in a nutshell here, it's important to know about these different storage services. And I guess on my end, I think the big takeaway is that I personally do like using some of the newer services like the Elastic File System because of the ability to use like traditional Unix-based workflows. And so if you haven't used those, it would be a great place to kind of dive into it. So great. We were able to get a lot of stuff done in an hour. And next week, I'm going to cover the final part of the Cloud Practitioner exam. And then from there, I think I'll probably move into the week after that, go into the Solutions Architect and go into that. And then also talk about some of the stuff I'm writing in terms of the C# on AWS book. So thank you again for showing up, whoever showed up today. And I'll see you next week.